voltage is a measure of electric potential. So let's actually talk about what that means. If we talk about potential in a kind of a classical physics sense, you might have this image in your mind that you get some kind of heavy ball and you lift it up above the ground a certain height, and then you kind of drop this ball and it kind of thuds down onto the ground, kind of crashes down onto the surface. And you might say that there's some potential energy in this ball, the gravitational potential energy here, because this ball can fall some height down onto the ground. So this is, let me just write this down. This is similar to, for example, gravitational potential energy. Gravitational potential, as you would have studied in your physics classes. However, for the case of electricity, what we have here is the potential for charge to do work. So for electricity, potential represents the capacity for charge. So remember, charge being, for instance, some electrons in a system, for charge to do some work, to cause some effect to happen, for example, lighting up a light or running a heater or turning a motor or so on, all of the things that electricity can do. So this potential represents this capacity for charge to do work. So it's measured in volts, and there's a particularly nice way to understand the meaning of a volt, right? The definition of a volt is the following. So we have that by definition, we have that 1 volt is equal to 1 joule per coulomb. 1 joule per coulomb. Okay, let's look at these pieces. So joule here refers to the amount of energy. So that's energy's capacity to do work. So we have 1 joule, and that joule, we're saying how many joules per coulomb, right? Coulomb is a measure of charge. So basically we're saying here how much energy do we have per unit of charge. So measured in volts. So equivalently, how much energy per unit of charge? That's kind of the question that is being asked by the measurement of a voltage. How much energy is there per unit of charge? And so it's this definition that 1 volt is 1 joule per coulomb. This is an important fact, and you should remember this. So you should remember that a volt is equal to a joule per coulomb. So yes, voltage is measured in volts, as I already spoke about. And let's remind ourselves one more time. I'll write this down. 1 volt equals 1 joule per coulomb. Very important fact for you to remember. Now, electric potential is always measured between 2 places. So when we had the example of the ball being lifted up, right, we had our ball, which was some height kind of above the ground, and we say there is some height in it here, right? We're talking about this potential energy of the ball with respect to the ground. We're saying that there's potential here because it can fall some height until it reaches, say the ground, and it kind of crashes into the grass. So for gravitational potential energy, it's always measured between two places, and electricity operates in exactly the same way. So electric potential is always measured between two places. So if I have an instrument that measures voltage, let's say a voltmeter, that instrument is always going to have two wires that come off it, or 2 points. And we will measure the potential from one location. I can kind of plug this into some part of my circuit, and it will measure the voltage, say, from one point to another point. So it's a difference between two places. The potential is the difference between two places. So it never makes sense to talk about the voltage kind of at a single point. So the voltage at a point only makes sense with reference to another location, or another point with reference to another point. So that's a very important thing to understand about how voltage actually works. So it's sometimes called the potential difference, to make this very, very clear, but just by the terminology. So sometimes called potential difference. Potential difference. So the voltage is sometimes called the potential difference, just to make that extremely clear. So alongside voltage, another important circuit parameter is current. So current is a measure of how much charge is flowing. So the thought experiment here is I have some wire, and through this wire there is flowing some electricity. Maybe some electrons are moving through this wire, and then I do this experiment where I could imagine that I had some plane, and I kind of cut through this wire, and then I ask the question, how much charge crosses this surface? So current is measured in amps. So we use letter A for amps. Current is measured in amps. And the definition, so by definition, we have that 1 amp is equal to 1 coulomb of charge per second. 1 coulomb per second. So if you have a current of 1 amp that is flowing through a wire, then you could imagine that you had some, say, rectangle, that imaginary rectangle that cuts through that wire, and if you were to imagine you could kind of sit there and count all of the electrons that run past you in 1 second, those electrons would add up to 1 coulomb of charge. So it's kind of a rate of flow. 1 amp is 1 coulomb per second. So yes, current is measured in amps, as already mentioned, and I'll write this one more time because it's extremely important. 1 amp is 1 coulomb per second. 1 coulomb per second. All right, there's an analogy here with water pressure, and sometimes people find this helpful in order to visualize what is the meaning of voltage and what is the meaning of current. And so the analogy goes that you can think of voltage as being very roughly equivalent to water pressure, and you can think of current as very roughly equivalent to water flow. So just creating that link. And this is a pretty rough analogy, right? This is not an accurate physical picture, but this might be a useful kind of mental image for you to think about when you're trying to understand the way that that electricity actually works. So you can kind of visualize here. So roughly speaking, voltage is akin to a pressure. So higher pressure would suggest more flow. So if you have a pipe and you put a higher water pressure into that pipe, you will get more flow of water. If you have a wire, or you have an electric circuit, and you put a higher voltage into the circuit, then you will get a higher current. So higher voltage will imply higher current. Now, not always. You can have certain circuit elements where this relationship is not quite so simple, but as a general principle, kind of most of the time, if you have a higher voltage, you would expect there to be a higher current flowing through that system. And of course, the other part of this analogy is to do with current and water flow. So again, roughly speaking, current is akin to flow rate. Right, so liters per second. You've got so many liters per second of water that are flowing through the pipe. It's a little bit like current. You have so many coulombs of charge per second is flowing through that wire. And so you can perhaps find that a little bit helpful as far as a rough visualization.